All right, guys, here we go. We have multiplication of multi-digit numbers using the area model. So my example up top, I have 96 times 8, and we're going to use that representing the area model. To do so, I'm going to go ahead and draw a rectangle. And I'm going to take my larger number of 96, and I'm going to first expand it into expanded notation. I know 96 expanded is 90 plus 6. So I'm going to write that on top. Now where I have my plus sign, I'm going to divide or partition my area model. So I have two different sections. And I'm going to label both the top and the bottom because I know they're both the same size. On the side, I'm going to represent my other factor of 8. So that is going to be the length of 8, and this is going to be the length of 8. All right. I'm going to include a double arrow on the corners of my model because this helps me better understand what to multiply inside. Remember, the area is what is inside of a figure, how many square or square units are inside. Okay, so in my first region, the length of this is 90 and the length of this is 8. So my factors are 90 times 8. So I know 9 times 8 is 72, so 90 times 8 is going to be 720. And I'm going to circle that because I'm going to need that number again. In this region, I have 6, and the length of that is 8, so I'm going to multiply 6 times 8. And we know 6 times 8 is 48. So now I have two answers, or in this case, we call them two partial products. I just simply take those partial products of 720 and 48 and add them together, making sure I line up each place value, the ones, tens, and hundreds. So I get 768. So my original equation of 96 times 8 equals 768. And that is my final answer. Okay? Now let's take a look at another example. I have a larger number, a 3-digit number, 374 times 6. And I'm going to use the area model once again. So let me draw my rectangle. And I'm going to represent my 374 in expanded notation once again. So I know that is 300 plus 70 plus 4. 300 plus 70 plus 4. Now I have two plus signs here, so I'm going to partition or divide my rectangle below my plus sign. So I have 3 different regions this time instead of 2. And let me go ahead and label the bottom part of my model. Okay, so I have 300 plus 70 plus 4 on top and on the bottom, and on the sides I have one factor of 6, which is going to be the length of that side. Okay, so like before, we are going to use the double arrows to help us understand what we are going to multiply inside of our model. And just like before, let's go ahead and figure it out. So the length of this first section, or this first region, is 300, and the length of this is 6. So I'm going to multiply 6 times 300, so I'll write my factors on top. I know that 6 times 3 is 18, and looking at my both factors, I have 2 zeros in 300, and none in 6, so I'm going to bring those 2 down. So 6 times 300 is 1,800, and now it gets a little tricky. What's going on inside of this area model? I know that this length is represented by 70, but there are no numbers on either side of this rectangle. So we kind of have to use our better understanding of what is the length of this. Well, I know this is labeled as 6, which is the same size as this. So we're actually going to multiply 70 times 6. I know 7 times 6 is 42, so 70 times 6 is 420. And then lastly, in this region, you have 4 times 6. My double arrows help me out. So we're going to multiply 4 times 6, which I know is 24. So now I have 1, 2, 3 partial products. Like before, we're just going to simply line up the place values and add them carefully. So I have 1,800, 420, and 24. Eight plus 4 is 12, carry my 1, and 1 plus 1 is 2. So my original equation, 374 times 6, is 2,244. And that is my final answer. Once again, guys, I always want to check my work just to make sure I'm confident. I know what I'm doing here. I want to check to see if I'm right. So I'm going to use 374 times 6 on my calculator. And yeah, I feel pretty confident about that. I get 2,244. And I mean, if you get the right answer, you got to do a dance. So